Okay, class, we're about to start section 5.7, which is negative exponents and scientific notation. We can think about the following division problem two different ways. We have x to the third power divided by x to the seventh power, and we want to solve this by writing out factors and reducing. So we have x to the third over x to the seventh. And so what we could write out is all of their factors. So we had x times x times x for the x to the third. And then the x to the seventh, we had x times x times x times x times x times x. Let me see, that's 6x's, so this is the seventh x. Okay, now we have their factors and we simplify out all the common factors. We have one set of x, two sets of x, and three sets of x. Now remember, whenever we simplify out everything in our numerator, that leaves us with 1. Our denominator, we notice we have 4 x's left, so we will write the base and we will have our exponent, which would be x to the fourth. And that is the final answer to this problem. Okay, now here we will use the quotient rule. The quotient rule goes like this. Whenever you have the same base, which we have here, we have x to the third over x to the seventh. We have the same base. The base is the x. So you would write the base, and then you would subtract the exponents. Now you would take the exponent of the numerator minus the exponent of the denominator. So we had x. This will end up being x to the power of negative 4. Now, if you notice, these two are equivalents. So x to the negative 4, as we see here, therefore we see that x to the negative 4 is the same as 1 over x to the fourth. And we can write that here as well. They are the same thing. Now, we scroll down here. We have this rule for negative exponents. If n is a whole number and b is non-zero, then b to the negative n equals, okay, so this is what happens. We have b, which is our base. We would take 1 over, our base will still remain b, and our exponent will become positive. That is how you do a negative exponent. You have a base to the negative exponent, it'll be 1 over your base, and the exponent becomes positive. Now, we have here, if n is a whole number and b is non-zero, then it's 1 over b to the negative n. Now remember, b to the negative n, first of all, I'm going to write this 1. And we know b to the negative n is 1 over b to the n. Now this is the same as 1 divided by 1 over b to the n power. Now we know this will become 1 times b to the n, or we could say b to the n over 1. So we'll make this 1 over 1, and we will have b to the n all over 1, which is b to the n. Now, I showed you the mathematical process of getting the final answer when you have 1 over, you have a whole number to the negative exponent. So it ends up just being that base and the exponent being positive. So what we could have did here, since you know the rule now, 1 over b to the negative n is just b to the positive n. Okay, now we scroll down here. We have example 1. We have b to the negative 4 power. We know, based upon our earlier definition, it's 1 over b to the 4th power. That is our a. Now we have our b. Now we have in parentheses negative 6 to the negative 2 power. So this would end up being 1 over parentheses negative 6 to the positive 2 power. So that would give us 1 over parentheses negative 6 times negative 6 in parentheses. So this would be 1 over 36. Now we go here to C. We have 1 over 4 to the negative 3. Now remember, in our example above, whenever you have 1 over a base to a negative exponent, all that becomes is you would just write the base and the exponent will become positive. So it'll be 4 times 4 times 4, which is 64. Now we look here at D. We have 1 over x to the negative 8. Now it's the same thing here. This x to the negative 8 would just become x to the positive 8. Well, I'm sorry, the 1 over x to the negative 8 would just become x to the positive 8th power. Now, we go down here. It says, be careful with a negative number raised to a negative power. They work differently depending on whether there are parentheses. So right here, we have negative 3 parenthesis to the negative 2 power. So we know that becomes 1 over negative 3 in parentheses squared. So this becomes 1 over negative 3 in parentheses times negative 3 in parentheses. So this will give you 1 over positive 9. Now we come here. Now remember, this negative is not taken to this exponent. So this will become a negative 1 over 3 to the second power. So that's equal to a negative 1 over 3 times 3, which is equal to a negative 1/9. Now see the difference between the two? This ends up being a negative 1/9. This ends up being a positive 1/9. Now we scroll down here and we go to A. We have negative 2 to the negative 3 power. So first of all, we have 1 over negative 2 to the positive 3 power. So it'll be 1 over parenthesis negative 2 times parenthesis negative 2 times parenthesis negative 2. So this would give us 1 over negative 2 times negative 2 is positive 4 times negative 2 is a negative 8. So our final answer is a negative 1/8. Now we come to B. We have negative 2 to the negative 3 power, and we know this negative is not taken to this exponent. So we will have a negative 1 over 2 to the third power. And so this would be negative 1 over 2 times 2 times 2. So this will give us a negative 1/8. Now these two end up being the same answer. That's because the exponent was an odd number. Okay, now we have C. We have 1 over negative 5 to the negative 2 power. Again, this negative sign is not taken to this power. So what we will have here is, it'll still be negative, and then it'll be 5 to the second power, which would be a negative 25. Now, one other thing I want to show you. I'm going to take this time out now. We know the rule, but sometimes we still probably should show the steps. So, let's go through and show the steps. We're still going to wind up with this negative 25. But showing the steps, we will have 1 over, it'll be a negative 1 over 5 to the second power, which is equal to 1 divided by negative 1 over 5 to the second power. So this will give us 1 times, we'll take the reciprocal here. The reciprocal would be a negative 5 to the second power over 1. So we know 1 times anything is the number itself. So this would be a negative 5 squared over 1. And we know this negative 5 squared will equal to a negative, and it'll be 5 times 5. And our final answer would be negative 25. Now I want you to write this because when you take an exam, you must show your work at least on some of the problems to prove to me that you know how to do this before you institute the shortcut. Okay, now we'll get to D here. Now D, it's the same thing. We will have 1 over, this would end up being 1 over parenthesis negative 5 parenthesis squared. So this would be 1 divided by 1 over parenthesis negative 5 squared. Now this would equal to 1 times. Now what I want to do here, this would be negative 5 parenthesis squared over 1. Now that equals, we know 1 times this value here will end up being this value here. So it would be negative 5 in parentheses squared all over 1. So we know this is negative 5 in parentheses times negative 5 in parentheses still all over 1. Now this equals to negative 5 times negative 5 is 25 all over 1 gives us 25. Now we scroll down here. It tells us to simplify. Now we have 1 over 6 times x to the negative 5th. So first thing we would do is this here. Now I told you sometimes you could use the shortcut. On some problems you have to show every step that you're doing. Okay, this problem here we're going to institute, well, I'm just going to show every step here. Okay, so first thing this would end up being is this here. This would be 1 over, we would have 6 times 1 over x to the 5th. Now what ends up happening here, we'll make this 6 over 1. So this would be 1 over 6 over x to the 5th power. Now what we would have here is, this is 1 divided by 6 over x to the 5th power. So this would give us 1 times x to the 5th all over 6. Now we know 1 times this factor here would end up being this factor. So it'll be x to the 5th all over 6. So this would be your final answer here. Now what I need to do here, just to clear up a little issue here, I need to take this 5 out and make this 5 the correct size, because remember it's an exponent, so it must be superscripted. So it'll be x to the 5th all over 6. Okay, now we go to B. Now we have x to the negative 8. That'll be 1 over x to the 8th power divided by y to the 3rd power. That is the same thing as saying 1 over x to the 8th divided by y to the 3rd, which is the same as saying 1 over x to the 8th. Now we want to put this y to the 3rd over 1, and we'll multiply by its reciprocal, which is 1 over y to the 3rd power. So our final answer here would be 1 over x to the 8th times y to the 3rd power. And that is our final answer for B. Now we come here to C. Now we have 5 times 1 over x to the 4th power all over 2 times 1 over y to the 8th power. Now we know this is the same as saying 5 over 1 times 1 over 4, which will give us 1 over x to the 4th, which will give us 5 over x to the 4th power, divided by 2 times 1 over y squared, 1 over y to the 8th will give us 2 over y to the 8th power. Now we have 5 over x to the 4th power divided by 2 over y to the 8th. Now we would change this division to multiplication. So we'll keep this first fraction the same, 5 over x to the 4th, times, we'll take the reciprocal of the second fraction, be y to the 8th over 2, and then we multiply. 5 times y to the 8th is 5y to the 8th, all over x to the 4th times 2 is 2x to the 4th. And that is your final answer for this problem. Now we're going to move on to D, but we will start D in the next video.